Hi again, everybody. Welcome. Thank you so much for coming tonight. Can y'all hear me okay? Okay, cool. I guess, yeah, if you can't hear me. Not really easy to answer that question, huh? Welcome to Reactor. We are a program with 11 different locations throughout the globe. We do in-person, hybrid, and live stream events that are free, open to the public, and are educational in nature. So we're trying to boost the AI entrepreneur and developer audience. We are very excited to have you in tonight. We've got two awesome speakers. We're going to have Matt joining us remotely, and we're going to be followed up with Sarah, who's going to give us a nice hands-on aspect of our workshop. Little bit just about our program. If you want to follow us, link up to our newsletter, learn more about any of events that we host here, you are welcome to follow that QR code right on the screen. It's a pretty cool, robust program. Obviously, I'm a little bit biased, but very cool, very interesting events. If you like something along this route, certainly look into our other events that are listed. Just real quick, we do have to mention we do have a code of conduct. We're asking that everybody please abide by our rules of courteous respect. We want to be professional. We want to have a good time, but we want to make sure everybody feels safe and feels like they're able to communicate themselves freely. So please be mindful of these. If you are not mindful of these little points, you can be banned from future Reactor or Microsoft events. So we don't want to do that. So behave. With that, I'm going to ask our speaker, Matt. He's going to turn on his microphone and he's going to turn on his screen. And I will turn over our attention to the screens. If I don't fall over, give me a minute as I switch this over. And thank you.
Hi, folks. How's it going? So my name's Matt. I am a program manager with Azure AI Search, and today I'm actually here to talk to you about something a little bit different. I'm here to talk to you about architecture recipes for AI-powered applications. Very specifically, these things called intelligent apps, and what are their use cases, and how are they going to work? So one of the interesting things about generative AI, there's been a lot of focus to kind of basically moving applications to the cloud. We're going to make them use Azure. I think the thing about generative AI is it's really changed the game when it comes to making apps truly intelligent. Now we've kind of opened up natural language as the next frontier of human-computer interaction. This natural language, like the ability to personalize, is much greater than we ever had before. We can also really quickly iterate on our applications and deliver new features. It's never been easier to add AI to your application. I think this really is a game changer for many things, because previously you had to do things like train a model, you had to spend a lot of time calibrating it. Now it's just as easy as kind of writing a single prompt for ChatGPT and you've added AI to your application. There's a lot of new things you can do. So let's talk a little bit more about how exactly this is affecting the overall market. Three really interesting stats. We think that every software company is becoming an AI company. Basically, with 1 billion new apps coming out that are going to use AI, about 80% of enterprises will have some way or form use generative AI to deploy applications that use this, up from 5% in 2023. This is pretty explosive growth, very explosive adoption. ChatGPT is one of the most fastest growing applications of the year in history, actually. When we talk about enterprises modernizing, 89% of enterprises are now saying, hey, generative AI is something I need to pay attention to. I need to invest in it. Unfortunately, there are a variety of challenges to fully realizing the benefits of these intelligent apps. So let's talk about a couple of them here. Number one, shortage of skilled developers. I personally don't think that ChatGPT is going to displace coders. I think, in fact, it actually makes it a little bit harder to code. You have a lot of new technology. How do I use it effectively? It basically requires retraining all developers to think about how do I use AI to solve this problem rather than a traditional way. Legacy app and data architectures. It can be very difficult to add generative AI to existing applications, mainly due to data bottlenecks and basically the way the application is architected makes it hard to add these AI components. Uh, it seems like every day there's a new paper that comes out about some AI technique that's not really compatible with your traditional, hey, every 6 months I release a CD in a box type software release cycle. Even Azure APIs are being released much more frequently to support new generative AI features. Uh, Though generative AI is very capable, it opens up brand new security threats to your application. You have to worry about a whole new slew of problems like prompt injection and jailbreaking, for example. You just didn't have to worry about these things until you add AI features to your applications. And finally, I think making sure generative AI use cases actually further your business outcomes. Uh, Things can demo well, but not add value. And a big problem is how do I actually pick the generative AI use cases that add value to my business? So the whole presentation we're going to get to today is about how do I actually use Azure services to address these challenges and deliver on the promise of generative AI for your organization. So when it comes to how do I use generative AI in Azure, like what's the actual benefits? I think it's really hard to understate like this is really going to make a big difference if you use generative AI to build things and in terms of shipping faster. We think that it's going to take you 50% less time to develop new applications if you use generative AI in the development process. Same way, 1.5 months faster to market for all brand new apps. And we think that if you use generative AI right, you're going to get a 150% increase in your work outputs due to Azure AI. And we've released a number of studies on this. We've worked with Forrester Consulting, which is a big firm that does a lot of research on enterprise AI adoption to prove this out. So we're really excited to deliver the value of generative AI to your organization. So when it comes to the entire Azure application platform all up, we are designing it specifically to help you deliver on the promise of building intelligent applications. The whole Azure integrated AI application platform is a full stack solution that encompasses developer services, application services, databases, and AI services. Every single element of our application development stack is going to leverage the same Azure security capabilities that enterprises trust every day to make sure that their data is secure in Azure. We take governance and responsible AI very seriously. When you use generative AI in Azure, you can trust that it's gone through a very intense and very vetted responsible AI process to make sure that we're not using AI responsibly and it's not generating unsafe content that you show to your customers. We want to build off of what you're already using to help your applications be intelligent. So this whole integrated platform builds on what's already in Azure. So let's talk about the Azure application platform all up. This is a comprehensive platform for all your needs, and this supports building intelligent applications from scratch, as well as taking existing enterprise applications and making them intelligent. So let's talk from just the left to right to kind of go over our offerings. We offer an enterprise-grade managed Kubernetes service with Azure Kubernetes Service. This is completely compatible with the open source Kubernetes, so you can lift and shift your existing application onto Azure. We also offer a platform as a service, Azure App Service, where you can build and modernize existing web applications, either from building from scratch or modernize existing ones. Basically using Azure App Service allows you to build these applications faster than building it yourself off Azure using open source. So if you also want to build APIs, let's say that like, hey, my organization, my business relies on providing APIs to other customers. We also offer Azure API Management and API Center for basically managing those products. I think our platform end to end, I want to highlight that like security is really important to Azure. We offer a number of things like code scanning, secret scanning, runtime, threat protection. We also offer advanced policy management solutions so that like, let's say that you have a specific rules that you need to apply to like how your business data is stored in Azure. You can monitor how that's used and enforce how it's used at scale. And we're bringing all of the generative AI features I talked about earlier into the actual developer stack. Specifically, I'm talking about GitHub Copilot, so that when you're writing code, you can leverage all these generative AI features to build your applications faster. So let's talk a bit about the Microsoft Intelligent Data Platform. That really we find what is key to maximizing your AI investments and productivity is to ensure that you're able to apply generative AI across your entire data estate and that this data estate is well organized and secure. The Microsoft Intelligent Data Platform encompasses a variety of offerings, including SQL Server, Azure Cosmos DB, PostgreSQL, Databricks, Fabric, many more offerings. Uh, we are going to offer you multiple modalities of these data platforms, ranging from infrastructure as a service to software as a service. And we're offering specifically Azure first-party databases like Cosmos DB, and we're also offering offerings from our strategic partners like Snowflake, Oracle, MongoDB. Uh, when you build on Azure using these offerings, you will get the most out of your AI applications. And you'll also be leveraging Azure security capabilities to improve your security posture and provide consistent security and governance policies. So let's talk a little bit about Azure AI Foundry. Azure AI Foundry is a trusted integrated platform. It's specifically designed for developers and IT administrators to get the most out of generative AI. We're offering a rich set of AI capabilities and tools through a single portal. We offer a single unified SDK, so it's very easy to understand how to build generative AI on top of Azure. Uh, and I think the developer tools I talked about earlier, right, like specifically GitHub, we also offer Visual Studio and Copilot Studio. Azure AI Foundry is natively integrated into all of these, so you can just get started building intelligent apps on Foundry using your existing tools. I want to talk about a couple key services inside Foundry, which will show up again and again in your generative AI applications. Uh, Azure, Azure OpenAI Service, which allows you to use the latest generative AI models from OpenAI, such as ChatGPT. Azure AI Search, which is used for building retrieval augmented generation applications. And Azure AI Agent Service for building intelligent agents. Azure AI Content Safety for making sure that the content you present to users from generative AI is safe and okay for them to view, and Azure Machine Learning as well for if you want to do your own machine learning models. All these tools can be combined with our rich set of observability features, such as evaluations, governance, monitoring, and we want to make sure that this also going back to the data estate. You can pull data out of wherever it's stored, whether it be in Fabric, PostgreSQL, SQL Server. Uh, so really, it's a single one-stop shop that unifies data, models, and operations into a single platform. So we offer a variety of templates to get you started in your generative AI application journey. These templates can be immediately deployed into production and used. You can use them to kind of showcase, hey, here's how I actually build a generative AI application on Foundry on Azure so that I can just get started. I don't need to waste a bunch of time reading documentation. I just like show me the code. These templates are for you. So we talked a lot about generative AI transformation. We talked a lot about the solutions Azure offers to make this real, but how do you actually make it real for your organization? And we really want to divvy this up into three use cases. We first want to start with like have to identify the intelligent app use case. Where will generative AI make a difference for a specific business outcome? How do I modernize an existing application or data estate to take full advantage of generative AI? And how do I operate it to make sure that I can actually deploy it at scale safely and with low latency, meeting all my requirements? So let's talk about a couple of use cases that we found for intelligent apps. So I think we think about use cases. We like to think about specific customers we have that have successfully used generative AI in their business in order to deliver more value. So let's go into a couple examples. So reinvent, so basically generative AI applications, when we use ChatGPT and other models like that to leverage natural language processing techniques, we can do things that we couldn't do previously. I think a couple examples. So let's go through this slide first. So ASIS, we were able to engage customers and present fashion recommendations based on trend data. JADO Dynamics, helping car dealerships produce tailored content by combining marketing data, Air India, creating a virtual assistant, which handles 97% of queries with full automation. DocuSign, pioneering a new category of agreements. These are all use cases that would have been very hard to build, potentially years of effort in machine learning that they were able to do much more quickly using generative AI. So let's talk about some other key use cases that you could use when building generative AI. So I think personalization is a really big use case. When users chat with generative AI, they're offering a variety of different inputs. They could be pasting images, they could be pasting text or writing messages to the chatbot like it's a person. They could be talking to it. You can use a lot of information using AI to produce actually personalized content for that specific user, which would have been very hard to do previously. Generative AI empowers something called semantic search, which basically involves searching on the actual meaning of underlying text instead of the just words in the product name. We can more personalize search and discovery to drive increased user engagement, make your users more satisfied with your applications. There's a couple key considerations you need to make when you talk about integrating generative AI for these personalization use cases. Namely, how do I integrate multiple data types into my application? How can I make sure that I'm leveraging pre-trained AI models like ChatGPT correctly so I can handle these multimodal inputs, speech, text, images, whatever you can imagine? And how do I actually scale it to meet the user demand? So let's talk about a specific solution that has been built on Azure before, specifically for personalizing product recommendations. So how can I take some raw data, namely my product catalog, my marketing campaign data, and the customer data such as purchase history, product reviews, and customer profiles, and actually build an intelligent application that will deliver real-time recommendations and customer experiences? So first off, we start by landing our data into two places. We're going to land our static content like PDFs and images into Azure Storage, and we're going to land our marketing campaign data, customer data into Azure Cosmos DB. We are then going to use Azure OpenAI Service, which hosts something called an embedding model. This embedding model is going to take the data from Azure Cosmos DB and turn it into vectors, a list of numbers that can power semantic search. These vectors are then stored in Azure AI Search to power a real-time search experience that actually takes into account the underlying meaning of the marketing campaign data rather than just the words inside of it. We're also going to perform a multimodal search over the images and PDFs that are stored in Azure Storage. We then were able to use this semantic search experience to power a conversational experience backed by ChatGPT through Azure OpenAI to actually allow our customers to chat with the campaign data. And we can also use the customer data we're storing in Cosmos DB to add personalization to this experience. Let's talk about another potential use case, accelerating content delivery. So if we want to generate more content that we can serve, generative AI is capable of actually generating images as well as text. So you could use this capability to automate the creation of either web or mobile content. And it's going to be much faster to actually iterate on your content. And you can potentially do A and B testing where you show different customers, different potential images or wording of marketing posts. Again, many of the considerations apply. How do I integrate multiple data types, multimodal data? How do I actually generate different text and images? I need to know more information about the user. And how do I actually integrate it with my existing marketing campaign or website content? So let's look at how a when we say multi-agent creative writing copilots, we're talking about a specific pattern in generative AI called agent, where essentially we get ChatGPT to prompt itself to get it to do a task. So in this case, we've segmented our application into four agents, basically four language models that have different personas and they're tasked with doing different things. The researcher agent understands how to call Bing search to search the web to find more information about some topic. The product agent understands how to use AI search to search a product catalog in order to get more information about products. The writer agent understands how to take the output of the research agent and the product agent and use it to write a creative post, maybe for a blog or a helpful article. And the editor agent critiques what the writer agent produce and worked with the writer agent to write a stronger article. And by putting this behind a web front end, you enable your users to effectively leverage AI to perform this really complicated task of writing an article without needing to figure out how to like prompt ChatGPT themselves. They don't need to go and like search the web themselves and copy paste. So we highly encourage you to check out the Contoso Creative Writer sample, which shows you how to leverage this agent pattern to actually write these articles automatically just with a simple prompt from the user, rather than having to go through a full expensive marketing flow where you have to work with a writer over many weeks to produce these articles. You can now produce them much more quickly. Another use case is transforming customer service. Customer service is a really common application for generative AI because it involves chatting with a support agent remotely over the phone or web interface. So essentially, rather than needing to route to a support agent every single time, you can save the support agent for really complicated cases or enable them in order to augment the chatbot rather than having to take on the full caseload themselves. So it frees up time both for customers who need support and the support agents so they can focus on more complicated cases. A lot of important considerations for this one, namely, how do I use chatbots to actually understand and interpret user queries? How can I summarize customer interactions with support? Can I use transcripts? Can I use the responses differently? How do I scale my chatbot to handle the load of many users chatting with it at once? And finally, how do I actually keep it fresh? Like if I'm updating my product, how do I make sure the support agent's aware of all the changes? So let's look at a sample application for support, namely with airline customer service. So again, we have our raw data. We have maybe a list of flights. We have information about customer accounts, metadata about the customers, like their name, and we have our policies around what support can and can't do. It would be really bad, for example, if the support chatbot offered a refund which was not aligned with the airline's policy. We're going to store all of this data into Postgres in this example architecture. We are going to then make sure that we use a cache. Specifically, we're going to use Redis to cache responses from our chatbot so that we don't need to go generate them every time. So like imagine if a customer asked the support agent, hey, can I get a refund on this ticket in this particular scenario? And we want to cache that response in case another customer asks that same question rather than having to regenerate it. We're going to use Azure Kubernetes service to host the backend of our application, and we're going to use Azure API management to wrap our API and make sure that we're calling it correctly. Azure API management offers a variety of useful services, such as like automatic rate limiting. It offers enhanced observability by creating a single point where you log things. So really good idea to use Azure API management as a central hub for your APIs. We're also going to deploy Azure OpenAI service to actually provide the chatbot functionality, and we're going to deploy Azure AI Search into the solution so that we can index the data from Azure PostgreSQL and have support semantic search over all the flight data, the customer data, and the policies. So this way, when the customers contact the apps are backed by the same APIs that will then go to Azure Search and Azure OpenAI Service to generate a response from the source of truth, the raw data stored in PostgreSQL, and generate a good response. The airline employees can also give input into the support agent. There's a customer support system that allows them to edit metadata about like, hey, what tone should the support agent respond in? Is there a specific response we need to give to a specific question? So a design like this enables you to get the most out of generative AI because you've landed your raw data into the Azure data estate in PostgreSQL. You've built an index for generating responses on the most relevant data using AI search. You're powering your chatbot using Azure OpenAI Service, which gives you access to ChatGPT. You've built your backend on Azure Kubernetes Service, uh, and you're using Azure Front Door as the single entry point for your application so that if you scale the backend, Azure Front Door understands how to route to different backends. So this is a very easy way to get global coverage on your application with minimal changes. So we have a demo about agentic copilot for content delivery. I don't have the demo ready for you, but I will try to show you the sample. So if we see here, uh, you can clone this template and run it yourself. But essentially, this is the creative writer demo I talked about earlier in the presentation. So you can clone this yourself and run it, and then see what it looks like to have a multi-agent writing sample that will actually compose blog posts and articles for you using the agent pattern where you have multiple AI models interacting with each other. Let's talk about another use case, accelerating product innovation. So what we want to do here is we want to personalize our services to specific customers. So imagine if I'm offering like a software as a service, I want to personalize that experience to that specific customer. Again, a lot of the same considerations still apply. Namely, we need to figure out a way to use generative AI to do this personalization. So in this example, we are talking about a personal banking assistant. We are using the agent pattern where every single agent specializes in a specific domain. There's a couple key architecture components here. Namely, we've got our Copilot Assistant app. Our Copilot Assistant app is a central hub for processing user requests. In this case, we're using Spring Boot as our framework, and we're going to use Java's semantic kernel to create agents equipped with tools. We have an agent router component, and the agent router component is what actually understands the user's intent, and it needs to route them to the specific agent that will solve their problem. We have an account agent, which specializes in handling all tasks related to banking account information, credit balance, register payment methods. It understands how to use APIs to actually manage account-related data. We have a transactions agent, which focuses on tasks related to querying bank movements, including income and outcome payments. Again, this also understands how to use APIs in order to do its tasks. Finally, we have a payment agent, which is responsible to solve all tasks required to submit a payment. This needs to use a variety of different APIs. In particular, it's going to interact with Azure Document Intelligence to actually scan invoices, and it also can keep track of transaction history. We all do this without changing any of our existing business APIs. So this is a case of taking a existing application and making it generative, making it an intelligent app. Again, there's another demo. You can clone this on the GitHub as well. But essentially what you can do is you can take the architecture diagram I showed you earlier, and there's real code backing it, so you can stand it up yourself and try it out. So let's talk a little bit about how more use cases for intelligent apps. Optimizing employee workflows. Medigoat Health is automating clinician processes, including report generation, and they're actually seeing that they got a 58% rise in clinician retention. Clinicians are also more satisfied with their jobs because they can focus more on caring for patients and not writing reports. Connectify detects 43% more suspicious activities and is making a decision 96% faster because they're able to leverage generative AI to detect fraud in transactions. H&R blocks are able to use semantic search to find more detailed client history. So they're successfully combining generative AI with search to do retrieval augmented generation. Volvo Group is also using AI to process invoice and claims processing. They've saved over 10,000 manual hours compared to previously before generative AI. Let's talk about another use case, knowledge mining. If I have a large amount of data, how do I look into that data and quickly find insights? How do I find patterns that are valuable for business decision making? This really requires an ability to extract relevant information and make it available for analysis at scale. And generative AI is a really, really good fit for this problem. So let's talk about, hey, how can I search over my data and perform knowledge mining? So if I have a bunch of raw data, in this case, I have call and text recordings, and I want to mine it for insights. I'm going to use Azure Functions, which is a serverless platform for basically performing work. So I can write an Azure function, my programming language of choice, host it on Azure. I don't have to stand up a server. I can just run it and trigger some kind of job to run. So in this case, when I upload recordings or text-based conversations, I'm going to trigger a transcription job, and I'm going to use AI to translate call logs into text, or I'm just going to take the text itself, and I'm going to upload it into Cosmos DB. I am then going to index that data into Azure AI Search. And once it's an AI search, I can actually now perform a semantic search over my data to find relevant insights. So this is a really common pattern of basically taking a bunch of raw data, processing it, and then storing it in a search index so that I can actually search it and ask questions about it. Like, what were the calls where they talked about a specific issue? So rather than needing to manually read over many transcripts, I can just search it instead. So we have another demo, which Sarah is going to walk you through more, where basically we're going to stand up a ChatGPT like front end that you can use for knowledge mining. You can use it to chat with documents. So this is a ready to use template that you can deploy. We have a variety of different resources at your disposal. Namely, we have free trials for a lot of our templates. You'll be able to try them at no additional cost. We also offer a variety of technical content. So you can check out Microsoft Learn. And really, there's a lot of resources we make available for you. So feel free to check any of these out. So you want to learn more about AI innovation, we have a lot of resources. Please visit the link akka.ms/AI apps, and we have a QR code that you can scan for more resources about developing intelligent apps. Thank you so much for your time.
Thank you, Matt. Thanks, Matt. We'll leave the slide up on the screen for you if you all want a moment to scan it. And before we bring Sarah up, I'll give you a couple minutes if you want to have a little jaunt around the reactor. We do have beverages available. Restrooms are down the hallway.
How about now? Gucci. How's everybody doing tonight? Good? Oh, pretty good, pretty good. Yeah, it is a Wednesday. Testing. I think I just got to hold it really close, but the mask makes it so I can't see how close it is. So I'm just, if I'm not holding it close enough, please let me know. See a few people coming back from the pizza. Yeah, so for this part of this is the hands-on part of the workshop. So if you have pizza, make sure you also have access or a clean hand to work on your laptop so you can kind of play along with us here. Out of curiosity, how many folks here have deployed AI or intelligent apps before or work on this for work? Okay, yeah. How many people are fans of Python? Okay, cool. We can be friends. .NET? Okay. JavaScript? Nice. Okay. The demo that I'm showing today is Python because I'm a Python developer advocate, but please do not despair. There's the exact same version of this demo in .NET and JavaScript and stuff, so you can choose the back end of your choice. Alrighty. Well, I think everybody is back now, so welcome everybody. I am super excited to be here in person speaking at kind of meetup things again. But my name is Dr. Sarah Kaiser. I'm a cloud developer advocate here at Microsoft, specifically for Python. So today we'll be talking about specifically, you had the great introduction from Matt earlier on kind of general ways you can build architectures for intelligent apps. And here we're going to actually dive into a specific, one of the specific ones Matt was talking about earlier today, which was doing an AI search on a RAG LLM. So we'll talk about what is RAG or these sorts of workflows, kind of show you what simple ones look like, how we can kind of keep turning on features to make them fancier, and actually, hopefully, all things working out right, you'll all be able to deploy one as well. So first of all, why do we need RAG? So probably raise your hand if you've heard of an LLM before. All right, probably. I'm assuming most people here. Also, I assume you've probably used them too, right? Whether it's playing around or in your editor to help you write the code that you really don't want to write. But yeah, so LLMs are great, but they do have some limitations. They can get out of date because they actually require you have to keep giving them the new information if you want them to know it. And say I want to ask it some questions about like maybe my health insurance plan or something like that for my employer. Hopefully it does not have access to those documents from, via the public internet. But so just the domain of what it has access to answer your questions can sometimes be somewhat limited. So we kind of have three main approaches to taking that LLM and making those responses better. The kind of lowest lift is usually doing prompt engineering, which is a whole nother topic, and I'm sure a lot of you here are getting pretty good at. You can then, on the whole other end of the spectrum, do fine tuning, which is honestly very time consuming and very expensive because that's where you're actually integrating new data into your LLM. So kind of the happy medium, which I realize now, why didn't I put it in the middle? But sequentially the order I wanted to talk about them in. RAG stands for Retrieval Augmented Generation. And basically what that is taking an LLM and giving it access to a kind of searchable data store of some description, so that basically it can combine the natural language powers of the LLM, and kind of what you might expect from a search engine, just kind of like a search box on like SharePoint or something like that. So you've probably already run into actual RAG systems in the wild. Anytime that you see a response from an LLM that has citations, that's actually a pretty good clue that there's probably a RAG operation running in the background, because it is only because it has access to those supporting documents that it can make those citations. So I've got a couple I'm using Teams, obviously, working here. So Teams can give you some citations in meetings. GitHub Copilot can give you citations when you're working in your workspaces. And Bing even can too, or any of the, if you search Google, the Claude, I think is what it's currently called. But yeah, all of those are basically RAG types of workflows. So what does that actually look like? We're trying to inch our way here towards the actual architecture we're going to need to implement this. But basically, here's an example workflow. I'm going to ask, how fast is the Prius 5? The RAG kind of system is going to do a search. Now, again, this is basically just like a data search of, here I have a bunch of data tables that are stored in a database that have all of these sorts of specs for cars and stuff like that. And so it's going to do that search first, and then it's going to pass those results to the large language model, and the large language model is going to take the results and try and both parse out what's important to me and summarize that back as a response in this chat style workflow. So you can, that example was pretty simple because the data was already in a table and we were just looking through a table. But you can also work with unstructured data, which I think is one of the most cool and powerful examples of something that's actually useful. So say you have a ton of tax documents, or you have your employee handbooks or documents like that. If you have a pipeline where you can take all of those documents, parse them, chunk them, and turn them into vectorize them, basically, you can now use those for RAG. So an example, to make that concrete, what would that ingestion workflow look like if I wanted to do this for a bunch of PDFs? So I'm a Pythonista, so I can use any tool that I could extract the text from that PDF. Sometimes I use PyMu PDF, but you could use Azure Document Intelligence, OCR things, anything that gets you that text. Then you need to split up that text into chunks. So sometimes that's, by sentence, or trying to keep tables together. There's tons of different tools, but a very popular community one that some folks here may have already used, for example, is LangChain. Once you have those chunks, you need to vectorize that data so that you can actually use that with your model. So here we're using the Azure OpenAI service. And then lastly, we have to actually, now that we've turned these chunks into embeddings, we need to actually store them somewhere. So you have lots of options, whether it's just a regular database, or Azure AI Search also acts as a store as well for these sorts of workflows. Cosmos DB, Postgres, SQL, whatever you like. Pretty much all of the major database frameworks have support for this now. So we kind of have about 4 different tasks here that we need to kind of plug and play and pick the tools that we want to use. We need to ingest our data. We need to have a way to retrieve it. So again, that's kind of the database search part. And then we need an LLM to actually be that large language model we can actually have the chat flow with. For the example here that we'll be looking at today, I don't have an orchestrator set up for it, just to kind of keep it simple. But if you're building up a bigger, kind of more complex app, you may want to use one of these orchestrators. Microsoft has a couple open source projects from Microsoft Research, being Semantic Kernel and AutoGen, but again, LangChain, Llama Index, there's all kinds of different open source options that are honestly all really cool and good, and just kind of what language and types of applications that you're looking for can help you decide which one is right for your project. But all right, so let's actually look at the app. That's kind of enough context. Let's look at the actual app that we're going to be playing around with. So you can, on your laptop, look at the code at aka.ms/ragchat. And if you want to, as we're going through here, play with the demo, it's just the same thing /demo. So there's a live version that is deployed already that you can play around with there. Hopefully that's short enough people got. But basically, this sample has OpenAI, Azure OpenAI, Azure AI Search, and Azure Container Apps with a TypeScript front end and a Python backend that's kind of playing the role of our orchestrator-ish here. But it can do simple and advanced RAG workflows. It can do conversations. It has optional vision and image integration, and there's all kinds of optional features with this demo that are super duper cool that you can kind of turn on as you go. Yeah, so let me actually just go to, and I have, yeah, okay, cool. So here's the actual live version of it. And you can see here there's two tabs at the top. So there's Ask a Question and Chat. Ask a Question is kind of the simple single shot RAG that we talked about already. You ask a question, it does that search, adds the context, and you get a response. So for example, if I just try one of these suggested ones, and for context here, the sample, it's Contoso company's employee handbook and a bunch of PDFs for that. So that's kind of the specific domain knowledge that it's going to have here because of the RAG workflow. So you can see here, all right, it tells me that what is covered, and it gives me a citation. So I can actually see then right here, the section where it's telling me from the actual source documents where it derived that answer from. And some of the cool things about this demo that honestly I find really neat is that you can see its thought process. So there's kind of this implemented UI for kind of seeing what's happening in this flow. So we see here at the beginning a bunch of the, it's also kind of like turning on debug mode, honestly. So you can see a bunch of the parameters that are turned on here. We're using vector search, we're using full text search, semantic ranker. So here when it gets responses, one of the advanced features is we can have it go through and look at the responses from the LLM, query it a few times, and then re-rank them depending on maybe we want to try a couple different LLMs as the responses and compare those. So we can kind of see the actual results from the model. And then we can also see the prompt here. So you can, for this example, this is using GPT 3.5 Turbo. That is a parameter for the demo, so you can use whatever is supported in the Azure OpenAI service. So, but yeah, you can see here it's giving us some of the context and all, basically just the JSON bundles that would be going back and forth between the front end and the back end. But we can inspect them here to see, kind of more information about what's going on in the back end. And if we go to the chat mode, it might seem like it's pretty similar, but if I ask it a question, you can see here we can actually continue to dialogue with it. So this is closer to probably what we've seen in a lot of other, like talk to chat GPT sort of windows where you can actually continue the conversation. It's not just kind of a one-shot sort of thing. So I asked it about what does a product manager do? I could say, okay, Then consider this while holding the mic. How do I get a promotion as a product manager? And I can actually continue this conversation, and it can make some recommendations to me about what I need to do if I want to get a promotion. I have actually gone down many rabbit holes here of just trying to see what it would actually say. And you can, this particular deployment of the demo also has a chat history. So you can actually see here on the side, you can go through and actually see kind of previous conversations, and if you need to, clear them. But if I look at my developer settings here, this is either the fun part or the frustrating part, which is all the different parameters and things that you can set. Some of the more basic ones like temperature for the LLM models, different parameters for the re-ranking step, how many search results for the actual kind of search component of this, because the more search results it presents to the LLM, that is more data, but that then also can be more data that can confuse the LLM in terms of what was the most relevant piece. So you can kind of play around with how many results it gets. And I also like having it sometimes suggest follow-up questions. So I can close that, and I think if I just reload this, let me try again. It should do at least suggest some more options here. I did do that, right? Maybe I need to hit close. Okay. Okay, so this is basically okay, there we go. There isn't really a save button, but here it gives you some more questions, follow-up questions. So again, this is actually using another round with the LLM to say, here was our conversation. It's handing basically the tokens for the entire previous conversation and say, all right, what might be a next question be? What might someone's next question be? So there are lots of cool options there, and these buttons kind of do mostly what you can pull up the thought process directly from any one of these responses that way. So yeah, let's actually, we kind of talked through this. It's always hard when I have a browser and slides for where do I show which. So yeah, we can do it with multiple messages round trip. So let's actually deploy it. Hopefully everybody here has an Azure account or some sort of subscription that they can play around with for this. You'll need access to the Azure OpenAI service and a couple account permissions. If it's a personal level one, most of those permissions should be fine. Whoa, come back here. If you have any trouble with any of this, I can come around once everybody kind of gets going. We can troubleshoot some of the if you're having trouble. But you have kind of three options here. You can do my favorite, which is go right to the GitHub repo page and deploy this template as a code space. So if you're logged into GitHub, basically this spins up a pre-made container on Azure with everything all set up for you. You literally just have to run AZD, it'll be 2 command line runs and it will go. So that's one option. You can also locally clone this repo and then again do the same. It'll be a couple command line options, but you'll be doing it in dev containers locally, or you can configure your machine with Python node and the Azure Developer CLI, whatever you prefer. I honestly recommend the code spaces for at least this kind of first run. So basically you'll only need to do 3 things to get this going. So I'm going to show you what it looks like. Let's close my previous. Go away, Teams control, please. So I'm going to go to my code space, called Super Space Disco. Sounds super fun, actually. So this is, I already spun this one up. So it's going to start up a little bit faster than yours might, but we should have, yep. So here I can see all the files for my repo. And it's basically going through just like if you were opening VS Code. This is actually a full VS Code instance, but running in your browser. If you have not played around with code spaces or dev containers before, come talk to me afterwards because they're my baby. Sweet. So it looks like we're pretty much ready to go here. So the first step from our slides here is we need to log into the Azure Developer CLI. So we can do that by basically running azd auth login and use device code. So you can just copy and paste. This is also, for the record, if you're trying this in the code space, this is also under the README here. Same stuff right here, so you don't have to keep going back and forth. But so to log in, I actually have to copy one with a specific tenant ID because I unfortunately have access to a lot of different Azure subscriptions. So I'm going to make sure I get the right one this way. So I'll copy my device code. Yes, I know what I'm doing. And now we get to play the auth dance, where you get out your multi-factor. It is cool that this sample is set up with all best practice sort of things. There's no keys, there's nothing. It's all set up with RBAC roles based on your actual deployment credentials. So you can configure user accounts and it can all basically be set up automatically, and you can manage all of that then through Azure without having to store any keys or secrets in your actual repo itself. So that's pretty cool. I'm going to put the mic in here for just a second. Okay. As you can tell, we have a lot of security. Okay. Cool. So that worked. Awesome. So now I just need to run, I'm going to tell AZD. So this is the Azure Developer CLI. How many folks have used this before? A couple hands. It's if you've ever used the Azure CLI tool, yes, they are different. This one is honestly kind of like a really helpful templating engine for deploying your Azure resources. I am not very good at going through and following like click workflows in the Azure portal. I very frequently forget where buttons are or things change. So as a developer, I really like having a tool that I can run like cookie cutter in Python, or these sorts of tools where it's infrastructure as code. So this is a command line tool to basically interact with Azure and infrastructure as code. So what you actually... All right, that probably was needed anyway. All of the information for how Azure is getting configured for this demo is actually in this infra folder. So you'll see a bunch of these bicep files. Bicep is the kind of markup language that describes resources in Azure. It's kind of similar to Terraform, and there are some resources that the Azure Developer CLI also understands Terraform files. So if you already have at your workplace or whatever a bunch of Terraform descriptions of what you deploy to other clouds, Bicep is pretty much the same thing but for Azure, and in some cases can also understand Terraform. So yeah, basically you can kind of see things like setting up the different model names, models for the ChatGPT resource. Mostly it reads like a lot of boilerplate, but the nice thing is if you have a question about how something's getting configured, you can actually go to the file and you don't have to find some panel pane somewhere and push buttons. So I'm going to start here, or continue rather, by creating a new environment. So this is kind of like effectively creating a new resource group for what I want to deploy to Azure. So I can do azd env new. And it's going to ask me for a name. So I'm going to put my initials, reactor demo. Cool. So you can see very quickly added a new folder here to our project directory called under .azure. So and basically has started a environment variable configuration file and one other kind of config file that as we go through the rest of the deployment workflow, as we set environment variables or other things are set automatically for us, this is kind of the exact what's being fed into all the parameters for those bicep files. So now all I need to do to deploy this is just run azd up. Boop. So this will probably take a little bit, so I will narrate some of this as it goes. So it's asking me now, okay, you want to provision some Azure resources. Who do you want to pay for them? So I'm going to pick my subscription for my Python team. And then it's going to ask me what regions that I want to deploy things in. This is probably the main place you may run into trouble when you're deploying this demo, is basically because the AI resource is in pretty high demand, they're not kind of universally available in all locations. So there's, I have a link I'll show in a sec. You can look up what regions have different services available. But when I tested this earlier, I'm going to use, I think, West US 2, which makes sense for us here. West US 2 for that. And the Azure or the OpenAI location, Japan East. So at that point, it has enough information that it can go and actually start deploying our project, which the first step it's doing, azd up kind of like puts a couple different steps here together. The first is azd package. So it's going through our actual app code here and turning it into effectively a zip file that will be turned into a Docker file for Azure Container Apps. So you can see it's actually running here an npm build process for the web front end for our actual chat client here. This will probably take a hot second, so we're going to come back here. Also, as soon as you deploy this, there are things in the basic configuration that do cost some money. So as soon as you're done playing around, like not like $100 a second, but like, you know, a couple cents for different things. There's lots and lots of really good documentation in the repo for this project of exactly kind of what things, where can you save money. And there's also environment configuration files where you can deploy it with only the free like tiers of everything. So the whole thing, you can deploy the entire thing for free. Obviously, then some of the ingestion steps can be a little bit slower and whatnot. So it's the default configurations for everything are kind of optimized to be as cheap as possible, but also still show you kind of the full functionality of the app. So, yep, it was going through and doing the packaging. Are we to provisioning yet? Yes, we are. So it did all the packaging. And I always like how it kind of narrates what it's doing here, because even as it's going now, because as I think a lot of folks here know, provisioning cloud resources can take some time. It actually gives me the link here, so I can, if I wanted to watch like on Azure or something, or I wanted to share a page with somebody, how my deployment's going, or why I went home early, I can actually send them this and see, what's taking. Okay, the OpenAI instance is taking a bit to deploy, and the search service, so everything else is pretty much trivial. So that's all going. Yeah, so we did the environment packaging, provisioning, and what to do if it fails. So if all things going well, hopefully this shouldn't fail. I didn't set this up to fail, but I did do that a lot when I was setting up earlier today because I was picking the wrong regions. And so basically it would have stopped a little bit sooner, and you get pretty decent error messages here that tell you kind of like, oh, hey, what you're asking for here doesn't exist in this region. Here's a URL to the docs page to help you figure out what might actually be helpful. So you can, yeah, so there's good feedback from the AZD tool to help you figure out what's going on. And for this demo, after everything is provisioned, which I'm guessing is still going to take us a while, but that's where basically the app starts up and does the document ingestion. So it doesn't, when we deploy that Docker container, it doesn't already have kind of the pre-parsed documents in it. Some version you can, as an add-on to this demo that you can find in the docs, you can have it where the user logs in and uploads their own documents. So maybe you're kind of like, I don't know, collecting a bunch of people's feedbacks from like a survey or something like that, and then you want to be able to ask questions across all of the different sessions. Maybe you're running a conference and you've got feedback from all the different talks and stuff like that. So the different owners could upload different pieces of information that would that this RAG flow then could have access to, and it would all go through the same pipeline. So after this is provisioned, the basic version here doesn't have that turned on, so it just goes through once, looks at all the PDFs that we have, and it's using the Azure Document Intelligence to extract the data, Python to chunk it up, just because it doesn't need anything super fancy. But that's a great option where if you were using a tool like LangChain or something like that, you could get real fancy with your chunking. And then handing it off to Azure OpenAI for the embeddings and using Azure AI Search to actually store those vector embeddings. Yeah. I'm going to check on it again. Okay, we're still going. It usually is done in less than 10 minutes, so I'm hoping we'll be able to see it finish here. But the kind of rough architecture of what we're actually deploying here is primarily we're interacting with the Container Apps web app. That's how we're talking to like the web page and the Python backend. We have the three main Azure AI Search is how we're actually doing the retrieval part. Azure OpenAI is where our LLM lives. And for the part where it actually shows you the citations in the web page for like, this is where I got that information, there's blob storage and also for ingesting documents. Blob storage for basically where the PDFs live. For the demo, we also have things like application insights and logging analytics set up. So those are kind of things if you're building something closer to enterprise scale where you really want to do all the cool monitoring and visibility sorts of stuff. And then it also uses a container registry and for the Docker image that's generated with the actual app in it. Yeah. Has anybody actually tried doing AZD up? Where we're going here? No? Oh, it's still going. Okay, cool. Yeah, mine is also still going. But we can then also this obviously does tell us search service is still going, but I can get, yeah, okay, that's literally the last one. Okay, that's cool. Great. Yeah, we talked about it's got a TypeScript front end, Python backend, and I have here, if you're kind of wanting to poke around at like where the actual pieces here live for the different. So like, let's say we wanted to change how that chat workflow, like the default prompts or something for that. We can actually start playing around with, this is the Python code for the Python backend that uses the OpenAI endpoint via Azure OpenAI to do those queries and responses. So we could go through and edit some of the options or settings here. Yeah, and I'm hoping that this will be, our deployment will be finished. Oops. Aha. That looks good. So, yep, it's got everything deployed. It's got everything provisioned. So basically we're packed up in the zip file. All of the Azure resources are there. Now we're actually sending the zip file up to basically build the Docker file that's going to be hosting our Azure Container App. So you can see this is some Docker output here, actually. And once it's up, since we do have some of the application insights hooked up, we can actually run AZD monitor. And I did test this in Codespaces earlier, but it should be able to show us then basically a dashboard, for some of the things that we're actually tracking in our app. Once that's done, I'll come back to that. I mentioned a bunch of optional features that are all implemented in this demo that you can try and turn on, but are just not on by default, mostly to kind of manage that additional cost slider. But it has support for Azure AI Vision as well. So like you can use speech and vision inputs to the model. So like maybe this was part of a like you're doing video interviews with somebody, like they could actually call in and chat with your HR rag or something like that. And the input could be processed from their call video, which does also help a lot with accessibility. You can create logins and stuff. So like I mentioned before, there's no hard-coded keys or credentials in the sample, basically following enterprise best practice for all of these resources. So out of the box, it's pretty easy then to just kind of turn, I think is literally just a parameter true in the bicep files that says, here, this is my Entra. I want to use Entra for login for this. Microsoft Entra ID is kind of the Azure authentication or one of the authentication products. So then as you can even set it up where like, if you had multiple different people uploading documents to this, like they would only then be able to RAG search the documents they had permissions to view. So you could have the system running and only if managers were uploading things that everyone else shouldn't see, then, all of that would just be baseline managed by Microsoft Entra. I mentioned the user uploaded documents. So it adds basically a little plus there. We looked at the chat history one. And yeah, you can do all kinds of stuff with the virtual networks. And this is obviously a public demo. Once you deploy it, it's a public URL. Definitely don't leave them up because security by obscurity is not security. But yeah, you can do all kinds of security stuff just by basically editing those bicep files. And lastly, there are some great examples in the docs for how to, so you've got this thing now. You've added all your documents, or you have a way for your users to add more docs, whether that's more PDF documents, or there are some other great examples in, if I go here. So this is the AI app template gallery, which I think Matt showed earlier. That's where you can find more information about this one we're looking at. But say, I had data that was in a Postgres SQL sort of scenario. I could do rag, just search here for rag. And here's kind of another example of this chat app where all the backend infrastructure just should much more easily work with where I have my data. So you've got lots of options here for each of those individual responsibilities. And something you may want to do once you can actually swap out or change some of those is actually see which ones work best. So there's some good docs in the repo for how to actually measure answer quality. There's these metrics that basically are provided by the Azure OpenAI service that have things like groundedness and relevance. And so you can go through where we were looking at changing some of the parameters here in the developer settings. If I was messing around with a couple different different settings here, I could actually measure the performance on a ground set of data. Basically, what you usually do is you come up with about at least 200 sort of question answer combos where you have a ground truth that's the actual answer to the question, and you can just script asking those questions and comparing the answers and seeing how well those answers match up with what you expect. So yeah, there's some great options for doing performance quality assessments. Yeah, so I had a bunch of time here for folks if you're actually deploying this or want to ask other questions about how to deploy stuff along these lines. Oh, that's cool. Sorry. Yeah, so does anybody have any questions? Yeah, go for it. Mhm. Um, yeah, that's a good question. Like when you have all those, so I'm gonna try and see if I can repeat that. When you have something that's doing semantic ranking of responses, so that's after you do in the sample here, there's the a ranking and re-ranking step options. So you've asked your query. It's possibly even there's a rewriting option. Then it goes to the search. So whatever's doing that kind of first retrieval of whatever data that we're looking to supplement our answer with. And then there's ranking on basically those responses. I know here. Hang on. I think I have a slide about that. One second. Because I had some stuff with more details. I thought about how the ranking and re-ranking worked, but I maybe don't anymore. So the question is why, like, why is it ranking the most? Because you were saying ranking the most relevant to the least relevant, right? Mm-hmm. Mm. Mm. Mm-hmm. Mm-hmm. Yeah, yeah. Right, right. Mhm. Ah, okay. I see. Um, I know a lot of the kind of it's effectively Python in this demo that's kind of doing that handoff. Um, I think there's a randomizer step. Like that's one of the options is you can just, especially when you're doing that kind of quality analysis sort of thing, you can just randomize the order in which the uh, effectively search answers are given to the LLM. So, um, I mean, I guess I don't know off the top of my head slash haven't sat down and like passed it individually and kind of tried to do that sort of evaluation. I'm a scientist by training, so usually I just try to like for intermediate steps like that. It You're right. Especially around keywords is usually where I see like if you have a word in the question, sometimes it will continue to over-index on that, even though if it's like the question is apart from X, what other options? Like, especially the longer you go, then it's like, oh, and here's more about X. And it's like, well, no, I was saying not X. So yeah, I think I generally tend to not observe at that state, but that is definitely, I mean, that's another way that you can play around with and try and see if you get better results. But in general, I mean, it's kind of a trade-off. The smaller context, more narrow you can narrow down that context to what you're handing to the LLM, the less likely it's going to hallucinate, right? Because it's exactly what you described about the longer the conversation goes, now you have more data that it's basically can get confused by. So, that, yeah, yeah, like they're really it's just a matrix getting multiplied by a vector in the end, right? Internally. So in my mind, it really shouldn't, all of the things being equal, shouldn't matter what order we hand them to the LLM in. But that's exactly the kind of things that I think a lot of folks play around with the different modules here for doing each of those different roles. So that's actually you would probably find a lot of settings for things like that in an orchestrator, and they would have lots of different strategies for doing stuff like that. Yeah, go for it. Uh-huh. Mm. To the best of my knowledge, you don't need to set up a lake house. Like, at least for what we're setting up for the explicitly here for the infrastructure, nothing is setting, I don't think, setting up a lake house, to the best of my understanding. Yeah, okay. Oh, from here? Uh, Sorry, where did you see that? Uh-huh. Ah, okay. Got it. Yeah, that probably would be a good, like if you're building up your own kind of where you're keeping your data and like the demo here, it's just a regular blob storage, like because it's just dumping docs, but obviously it's not to the scale where we would need a lake house. But that's a really good question because that's a much more realistic scenario for where you would actually have data for, and especially mixed kinds of data. Uh, Rather not specifically in the one lake house, but like Microsoft Fabric allows you to have kind of a single, and that's a really great. I think there are some examples with Fabric in here. Uh, Uh-huh. Oh, got it. This being uh mhm, okay. Yep. Mhm. Sure, 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 sure. Mhm. Um yeah, no, that makes sense. That makes sense. Yeah, I do know that it obviously does work very well from some of the larger data store products like lake houses and stuff like that. Um, I haven't used I haven't actually used stuff from there. I've used stuff from the Fabric API before, which unfortunately obfuscates all of the details behind that for how it configures. But I can definitely get much more. I'm happy to chat with after and make sure we get your questions answered for sure. Anybody else? Yeah, go for it. Yeah. Ah, yeah, yeah. Yeah, so how I understand this is basically you can we were talking earlier about how sometimes the search results like do I have an example? Like after you do the search step, sometimes those sections of the documents that it identifies can be pretty big and can be distracting. So basically, this is taking at another step, injecting an LLM to summarize those chunks to then basically there's two main reasons you'd want to do that. One, to save on tokens. So if you're trying to do something, minimize your token usage or basically keep costs down, you could take that blob, reduce, if it was going to be half a page, now you send a sentence or two, which is a big token savings, but also can then hopefully help focus, whatever is going to be the next step and actually answer the query from the user. Obviously, every time you do something like that, now you've introduced another step where hallucinations can happen. So that's, I think, something where I would definitely have good groundedness testing set up ahead of time. Then, turn that switch on and just check to see, to make sure that, whatever model you've chosen and everything for that semantification step, that middle step, which that isn't the only place that you can do this here. There's also a query rewrite step that is actually turned on in the basic version of this demo. If I mean, which let's see here. Actually, I can probably tell from here. So my question, what else? That's not a super, if I was being a good prompt engineer, that's not a really good question that I should be asking. So that's the context. Do I see can I find where it actually, it looks like it did not edit so there is a rewrite step where basically if it, um, which I think I have an example of. Yeah, so an example of a flow where you'd have an LLM right after the query. You were asking about health plan stuff and you just said hearing to, like that's not a good thing to search for. But then you can have the query rewrite it, or in my case, often fix all the spelling mistakes to then actually pass a much better keyword search to your search retrieval step. So does that help? I in my personal experience, the rewrite step is much is better. Like do it before you get, because you really, that search is where you're getting hopefully the most relevant data. So being able to better form, it's kind of like when you learn how to get good at internet searching rather than just like, why isn't my Python working? Like being able to be like, all right, Python, pandas, sort table or something, basically that step of trying to turn it into good search keywords. The better you can kind of tune that step, I think the better the performance in general really ends up being. Any other questions? Did anybody else manage to get a deployment going? Did it work? Awesome. You seem so enthused. I usually, my dog always knows when my deployments work because I'm like, yes, and then he comes and checks on me. He's like, oh, are you okay? Anyway, yeah. Any other questions, comments, concerns? Yeah, for sure. In this Azure or the AI app template gallery, a lot of the other samples have different orchestrators. So if I have LangChain, thank you. Okay. One that's listing LangChain. Probably a lot others with some of the semantic kernel and some of the other Microsoft orchestrators. But yeah, so here's an example that uses the orchestrator will probably be in the somewhere between the API here and the web app. But hopefully that we can just, oh yeah, that button actually literally just takes you to the code space. I want the code. Thank you. But yeah, so there's definitely a bunch of options there where you can kind of see different tools used for different, whether you use Azure Cognitive Services for the document ingestion, or maybe you're using something other than Azure AI search. Like it is pretty plug and play. Yep. Mm-hmm. I mean, there's a lot of different input parameters there for which is cheaper. I think at a base level, no, but I think it does scale better. That's at least my nominal understanding. We're actually building some new samples. Cosmos DB's got a lot of cool stuff coming down the pipeline right now for making the integration and experience here with Azure OpenAI services, as well as the whole Azure AI Foundry setup, like real slick. So I'm looking forward to testing and breaking a bunch of those in the next couple of weeks. Yeah, all kinds of different, basically we're building up a bunch of example galleries for using Cosmos with kind of all of these AI sorts of driven workflows. And I think, yeah, that's what I can say about that. Yeah, cool. I'll be around for a little bit if anybody wants to not talk publicly or is nervous. But yeah, hopefully you had a good taste of kind of what one of these RAG demo apps kind of looks like. Play around. That the endpoint is live, so like if you want to share that with other people, just aka.ms/ I think it's just RAG chat. So you can kind of play around with some of those other features. Awesome. Thanks, everybody.
Thanks, everyone. I will keep our building open until 8 o'clock, but when it closes at 8 o'clock, it is severely closed at 8 o'clock. You're welcome to please take some pizza home. If any pizza is left here, don't worry, it will not go to waste. but I encourage you to take it with you. It's going to be a lot better there. And thank you for coming. Get home safe.